All right, good morning, everybody, or good afternoon, I suppose. Just here to introduce you into your next lesson. Thank you very much to whoever's covering this lesson. Again, it's very much appreciated. We should have gone over efficiency with Miss Calvert yesterday. I just want to do a quick recap of that so that you know what you have to do for today's lesson. So a reminder that if I have got 100 joules of energy that's available in a system, so let's say it's a car or whatever, we've got 100 joules available. Let's say that we use 60 of those joules for kinetic energy as we are driving, and 40 of those joules are wasted as heat energy from the engine. Then this 60 joules we would call useful energy. And this 40 joules, it isn't being used for something that we want our car to do, so we want our car to move forward, we will call this waste energy. Efficiency is a measure of how much useful energy there is in the system compared to how much waste there is. So the way we find this then is we use the equation efficiency is equal to useful energy divided by total energy. So whenever we get a question about efficiency, we always have to first identify what's useful based on the situation. So this is the situation of a car that is moving along the place. So obviously the kinetic energy is what we want. So efficiency then, reminder as well, Ms. Calvert should have told you, I'm going to say it for you again, that when you're doing any kind of maths, we have to follow the same method. On the left-hand side, you collect terms. What does that mean? Well, we've got to get our pen and we've got, we say, right, there's a certain amount of efficiency. I don't know what that is, but I have to calculate it. The useful energy will be the energy that is in the system that is doing what I wanted to do. So in this case, if I look back up at the scenario that I had, we're saying 60 joules is useful energy. We have to find the waste energy, which is 40 joules, and we're going to have to find the total energy that's put in, which is 100 joules. Now, if we have our useful and our total, then we don't actually need our waste, but it's always a good idea to pop it in just while you're doing the calculation, just in case they're asking you something silly later on. We then have to write out the equation that we're using. Efficiency is equal to useful energy divided by total energy. Efficiency will therefore be the number that I have for useful energy, which is 60, divided by the number that I have for total energy, which is 100. That'll give you a number between 0 and 1. 0.6. Now, if you want to, optional, after that, we can multiply it by 100 to give us a percentage. So that would be 60%. Now, when I come back in a couple of weeks' time, I would like to see every question that you've done using, or any question that you've done on efficiency using this method, okay? Every single thing, collecting terms and then showing the working out. Now, there are a lot of questions for you to do in today's lesson. It will take you a bit of time. They're not all maths questions, so what does efficiency in the appliance tell us? Do your best to answer that. Remember that you can use your knowledge organizer if needs be. Sorry for this, folks. I'm writing with my my mouse. I'm getting better at it, but there you go. So these are some wordy questions for you to try and have a go of. And then we've got some efficiency questions here. Now, what I'm going to do is I'm going to do the first couple, just so you can see what the heck? So you can see precisely what you have to do. I apologize. They've updated this very usefully into a worse version of the software. So I'm just trying to get used to it. So here's my question then. A light bulb uses 470 joules of energy. So that's the same as saying that my total energy is equal to 470 joules. It produces 180 joules of heat and 290 joules of light. Now, I want my light bulb to give light, so that's useful. This is heat, so it's wasted. So I'm going to put down that my waste is equal to 180 joules, and that my useful energy is equal to 290 joules. Calculate the efficiency of the power station. So it's asked me to find efficiency. Oh no, sorry, pardon me. Calculate the efficiency of the light bulb. Efficiency equal to, I do not know how many. I'm going to write down my equation. Efficiency will equal useful divided by total. Efficiency will equal the number that I have for useful, which is 290, divided by the number I have for total, which is 470, giving me an answer of, let me just get the calculator. 290 divided by 470, giving me 0.617. Where's my pen? There it is. Okay, 0.617. I'll put that to 0.62, and then I can do it if I want to, multiply by 100, and then get 62%. So that's how you're going to do it every single time. Now, just for the sake of it, and in case Ms. Calvert didn't give it to you, I'm going to give you the rearranged equation: useful divided by total. That total energy is useful energy divided by efficiency. Useful energy is efficiency multiplied by total. So there are the three equations that you're going to need for all of these. For all of these equations. I'm going to undo that because it's not a useful line. Once we've done all these questions, please move on to the ones on the other page. And if you've done all of those, you can either go onto the extension task that's listed in the cover folder. You can go into WHA Science and do some more efficiency calculations. There should be 5 iPads in the room for you, or you can do the tasks that you haven't done yesterday. And as always, if you've got any questions, please email me and I'll get back to you as soon as possible. Good luck.